Hello viewers, as part of the series on nomenclature of organic molecules, today I'm going to tell you how to name bicyclic molecules in the most simplest way. So stay focused and watch till the end. First, let's see what bicyclic molecules or bicycloalkanes mean. So these are molecules with two fused rings. In other words, you can say that two rings have two carbon atoms in common. Sometimes we call them as bridged molecules. So this is an example of a bicyclic molecule. You can see there are two rings which are fused together and they have these two carbon atoms in common. And we call these two carbon atoms as the bridgehead carbons. Why? Because the bond between these two carbons, it's acting like a bridge between these two rings. So these two carbon atoms form the bridgehead of this bridge. Now let's see how we can name them according to IUPAC nomenclature. So first you need to know how to name the skeleton of a bicyclic molecule. So this is how you can name the skeleton. So first you have to write the prefix bicyclo followed by the square bracket. Now in the square brackets you have to write some figures, and that would be the number of carbon atoms on the side having higher number of carbon atoms. So you can have two rings with different number of carbon atoms. So first you have to mention the number of carbon atoms on the side having higher number of carbon atoms, followed by a dot, and then you write the number of carbons on the side having lower number of carbon atoms, again followed by dot, and finally you write the number of carbons on the side having least number of carbon atoms, and then you close the square brackets. This will be followed by the name of the corresponding alkane having similar number of carbon atoms as you have in the bicyclic skeleton. So let's see this with the help of an example. So we have again this bicyclic molecule. So what you need to do is to write the prefix bicyclo and then you open the square brackets. First you have to write the number of carbons on the side having higher number of carbon atoms. So if you look at this bridge, this right hand side, the blue side, has 1, 2, 3, 4 carbon atoms, and the left hand side, the black side, has 1, 2, 3, 4 carbon atoms, and in between these two bridgehead carbon atoms there are no carbon atoms, right? So we have two rings or two sides with similar or highest number of carbon atoms. So what you need to do is to write bicyclo first and then open the square brackets followed by the figure 4, because this is the highest number of carbon atoms that you can have in this molecule, that is on both sides. So you just write 4 dot, then the next higher number of carbon atoms again is 4, so 4 dot 4 dot, and then the least number of carbon atoms is 0, so this would be 4 dot 4 dot 0, and then you close the brackets. This will be followed by the name of the corresponding alkane having similar number of carbon atoms. So if you count the number of carbons in this molecule, you have 10 carbon atoms, and for a corresponding alkane having similar number of carbon atoms, the name is decane. So finally we have the name as bicyclo. Then in square brackets you write 4 for this side, dot 4 for this side, and then dot 0 for this side, and finally we write the name of the corresponding alkane, that is decane, because this molecule has a total of 10 carbon atoms. Now, what are the IUPAC rules for numbering of the carbon atoms in the two rings? So obviously you have to number all the carbon atoms in both the rings. Remember that in this case, the numbering will always start from one of the bridgehead carbons. You have two bridgehead carbons, and the numbering will always start from one of these two bridgehead carbons. And then it will proceed in the direction of the ring that has highest number of carbon atoms. So you start from the bridgehead carbon and then you proceed on that side which has highest number of carbon atoms. Again, let's see this with the same example. So we have these two bridgehead carbons. You can start numbering from any of these two carbon atoms, right? So this would be your carbon number 1, or either this would be your carbon number 1. And then you proceed in the direction of the highest number of carbon atoms. So you can see here we have 4 carbon atoms. Here you have 4 carbon atoms, and in the center you have no carbons, so 0 carbons in the center. Now in this molecule you can start from any of the bridgehead carbons, and then you can proceed either to the right or to the left, because the right and left hand side both have similar number of carbon atoms. So the numbering would look like this. If you start from here, you can proceed either on the left hand side or on the right hand side, because both have similar number of carbon atoms. So this would be your carbon number 1, 2, 3, 4, 5, 6, the second bridgehead carbon, then 7, 8, 9, 10. So again, the name would be Bicyclo 4.4.0 decane, because there are a total of 10 carbon atoms. Now this is for a skeleton that does not have any substituents, but you can have some substituents on this bicyclic molecule. So if you have substitution, what would be the IUPAC rules? So again, the first rule is that you start numbering from any of the bridgehead carbons, and then the numbering will always proceed in the direction of the highest number of carbon atoms. So substitution here is secondary. You don't have to bother about the position of the substituent here, but what you need to see is that which side has the highest number of carbon atoms. So you start from a bridgehead carbon and then you proceed in the direction that has highest number of carbon atoms. But because you have two bridgehead carbons, which of these two bridgehead carbons will be your carbon number 1? And that will be decided by the position of the substituents. So you have to start from that bridgehead carbon from where the substituent has the lowest position, right? So that will be your correct numbering. And for writing the name, the positions and the names of the substituents will be written first, followed by the parent name. So let's see this with the help of an example. So we have this bicyclo decane again, but this time it is substituted with a bromine atom. So again, you have two bridgehead carbons. From which bridgehead carbon should you start? We have 4 carbon atoms on both sides, right? So you can see here we have 4 carbons on this side, the blue side. We have 4 carbons on the left hand side, and we have no carbon in between these two bridgehead carbons here. Which of these two bridgehead carbons will be your carbon number 1? So let's see if you start from here and proceed in this direction, which you can do because this side has 4 carbons as well as this side has 4 carbons. So you can move in any direction. So if you start from here, then bromine will fall at 1, 2, 3, 4. And if you start from here and you proceed in this direction, then bromine will fall at carbon number 8, right? And if you start from here and proceed in this direction, then bromine will fall at carbon number 9. However, if you start from here and proceed in this direction, then bromine falls at 3. So this is the best way the best way to number the carbon atoms in these two rings. So you start from this bridgehead carbon and proceed in this direction, and that will give you the lowest position for bromine atom. From here you can have it at 4 or 8, and from here you can have it at 3 or 9. So 3 is the lowest position that can be assigned to bromine in this case. So we start from here and we proceed in this direction. So this will be the correct numbering, and now you can see bromine falls at 3. So this would be 3-bromo bicyclo. In the square brackets you write 4, 4, 0, and because it has 10 carbon atoms, so the name decane. Let's see another example. Again, we have a bicyclic molecule, but this time the rings are different. This side of the bridge has 4 carbon atoms, and this side of the bridge has 3 carbon atoms. So you can see here on the right hand side we have 4 carbons, on the left hand side we have 3 carbons, and in the center here we don't have any carbon atom. Again, you can start numbering from here or from here, but in this case we have different number of carbon atoms on the left and right hand side. So if you start from here, you have to proceed in this direction, or if you start from here, you have to proceed in this direction, right? So if you start from here, then bromine will fall at 1, 2, 3, 4, 5, 6, 7, 8, and 9. But if you start from here, then bromine falls at 1, 2, 3, 4, 5, 6, and 7. You cannot start from here and proceed in this direction because bromine will come at 2, because this side does not have the highest number of carbon atoms. So in any case, you have to move in the direction where the number of carbon atoms are the highest, right? So from here, bromine falls at 9, right? Because from here you will proceed in this direction, and then bromine will fall at 9. But from here, if you start from here and proceed in this direction, then bromine falls at 7. So 7 is the lowest position that could be assigned. So you start from here and then bromine falls at 7. So this would be 7-bromo bicyclo. Now in this case we have 4 on the side having highest carbon atoms. On the left hand side we have 3. So we write the highest number first, followed by the second highest, and then followed by the third highest. So this would be 4, 3, 0, and because this skeleton has 9 carbons, so the name nonane. Let's see some more examples. Here we have a molecule, again a bicyclic molecule, and according to the rules, you know that the numbering will always start from the bridgehead carbon. So these two are the bridgehead carbon. So we can start numbering either from here or from here. So one of these two will always be your carbon number 1. And then you see the number of carbon atoms. You count the number of carbon atoms on either side, right? So from here, on this side, we have 2 carbon atoms here. On the left hand side, we have 2 carbon atoms. And in the center, now we have 1 carbon. In the previous cases, we did not have any carbon in the center here, but in this case, we have 1 carbon atom. So you start from one of these 2 bridgehead carbons and you proceed in the direction having highest number of carbon atoms. So the highest carbons in this case that you can have is 2, and that is on either side of this bridgehead carbon. So you can start from here and proceed in this direction, or you can start from here and proceed in this direction, right? So let's see how it's done. So you start from here and you proceed in this direction, 1, 2, 3, 4. Now from 4 onwards, you have to proceed towards that side, which again has higher number of carbon atoms. right? So again we have two sides, one having one carbon atom and the other having two carbon atoms. So from 4 we move to this side, 5, 6, and finally 7, right? So it's a heptane, a bicycloheptane. But what will you write in the square brackets? We have 2 on one side, 2 on the other side, and 1 in the center. So this would be bicyclo 2.2.1 heptane. Let's see another example. Now we have a bicyclic molecule. Again, it's not substituted, so you can start numbering from any of these two bridgehead carbons. So we start from here. This is your carbon number 1. Now let's see on which side can we proceed. So count the number of carbon atoms on all the three sides. On the right hand side, you can see we have 2 carbons. On this side again we have 2 carbons, and in the center now we have 2 carbon atoms. So you can start from here and you can proceed in all the 3 directions, like in this way or in this way, or you can even start from here and proceed in this direction, because all of the 3 sides have equal number of carbon atoms. So in this case the name would be bicyclo 2.2.2 octane, because now we have 8 carbons in the skeleton. Now if this skeleton is substituted, right, so we have the same molecule, the same skeleton, but this time it is substituted with a methyl group. Now from which bridgehead carbon should we start? You have to start from that bridgehead carbon which would give the lowest position to this CH3 while moving to the side that has highest carbon atoms, right? So if you start from here, right, first you have to see how many carbon atoms are there on all the 3 sides. So again we have 2, 2, and 2 carbon atoms. So you can start from any of these 2 bridgehead carbons, and then you proceed in any direction because all directions have similar number of carbon atoms. So if you start from here and you proceed in this direction, because you have to see the position of the substituent now, because you have equal number of carbon atoms. So the first rule is gone. The second rule is that you have to look for the lowest position of the substituent. So if you start from here and you proceed in this direction, the CH3 group will fall at 1, 2, and 3. But if you start from here and you proceed in this direction, CH3 will fall at 2. So you have to start from here and then you proceed in this direction, right? So this would be your carbon number 1, followed by numbering of all the carbon atoms. So this would be 1, 2, 3, and 4. Now from 4 onwards, you have to see on either side here which has the highest carbon atoms. Now both have 2 carbon atoms, so you can proceed in any direction. So from 4 we move to the left hand side, 5, 6, and then finally 7 and 8. So this is how you number the substituted bicyclic molecules, and the name here would be 2-methyl, because at position 2 we have a methyl group, then bicyclo, and in the square brackets again you will write 2, 2, and 2, 2.2.2, and finally we have 8 carbon atoms, so this is octane. So this is how you can name simple bicyclic molecules. Thank you for watching. Thank you for joining. See you later.